Hey everybody, this is Larry. I'm doing the Leetcode Contest 183. Uh, yeah, so we have about 40 seconds left. So take time to hit the like button, subscribe button, or whatever buttons. Leave a comment. Yeah, I've been doing not so hot lately. So my goal today is to kind of slow down a little bit and force myself to really, not be lazy and be a little bit deliberate. I've been rushing it a little bit, even though I ultimately know how to solve things. I don't know. I've just been very careless with a lot of wrong answers. So yeah, that's kind of my hope and my goal, and we'll see how it goes. Wish me luck again. Hold on, keep watching, I guess. Here we go. Here we go. The first one. Yeah, it's the first one. I actually took 2 minutes on this one. Yeah, I think to be honest, I think I was just a little sluggish waking up on this one. Because definitely, uh, I mean, the algorithm I got okay and wasn't that slow, but my coding was horrendous, as you'll see here. Um, I think I was not understanding the problem also as well enough, but I knew that I need to sum it. So that's essentially what I did first. But then from then, I went a little bit weird, to be honest. I also took a long time reading. I think I should have known already. Yeah, but basically I sorted the nums and then I reversed it. Um, and I just keep track of, the rolling sum. And then count that against the total. I think I mentioned this later on the explanation. I do this very rarely. Basically, I do this n square, and it is deliberate. But while I was coding this, I was like, n square is okay. But it definitely is an O of n algorithm, because even though n is only 500, it's okay. But but yeah, you could kind of see me like uh, getting uh, getting into it a little bit because it didn't really make sense. Um, But yeah, so this part's okay, but because of the way I did this part, it is very weird. So I basically, yeah, do not recommend this on an interview, obviously. Um, but but yeah, I mean it works. It's just that it is ugly, and you could do it in linear time quickly. Okay. Number of steps to reduce a number in binary representation to one. So this one is a little bit interesting. So I was like, oh, it's a string, but you look at the n, and n is 500. That means it's a long binary string that cannot be represented in a 32-bit int or 64-bit int for that matter. Um, needs a 500-bit int. But guess what? Language has a 500-bit int. So that's essentially what I end up doing. I was a little bit, to be honest, I was just lazy. So I was a little bit not confident in running time just because you never know with big nums. I mean, you could do the math, but I haven't done I don't think in general I needed to do big nums in a long time, so I'm just not familiar with it. But I was trying to do some fancy things. I was like, no, wait, because if S is a string, so you might have to do some because your map, your int may not be right. Um, yeah, so I literally converted it to a binary number in Python. That's 500 digits or 500 binary digits in any case, and then just did the algorithm. Um, Yeah, and then now I try to construct a really big number. I should have used all once, maybe. Yeah. So the right way, or the recommended way to do this is just keep track of the carry bit and keep on adding as that number comes up, and then propagate things up. You're only ever going to carry up, so yeah, you're never going to carry more than one. So yeah. So after that, I was like, okay, good. Longest happy string. So here, now I am happy that I know I'm running good pace at this point, about 4 or 5 minutes in. But this was a tricky problem or an ad hoc problem. My first intuition was dynamic programming, but I also was in the back of my mind figuring out that there's a heuristic algorithm or like a greedy type strategy type algorithm that makes this ad hoc. I also think I misread this a little bit during the time. I thought that it was A plus C, well, A plus B plus C is less than 100. It doesn't actually change the complexity all that much, but it made the dynamic programming slightly faster, or like, you could say even like 6 times faster or something like that, because it's n choose 3 instead of n cube. So, but unfortunately, because of that, I did get a one-time error though. Because of that misread, I did not test the absolute worst case, though I should have, and then I got time limited exceeded. But yeah, I think at this point I was still just trying to do the math to see whether this would run in enough time. But yeah, I think in the beginning of these ad hoc problems, you just try to figure out to see if you figure a pattern. And I think at this point, as you kind of see, I kind of was like, okay, I convinced myself that dynamic programming is good enough, and here we go, off to the races. So I did this actually really dumb even that here, is that, and some of this is, I'm going to blame it again while I can. You could just roll your eyes if you like. I'm going to blame it on being a little sluggish, because, don't know, I mean, I guess I could normally do that in a regular day too. But there's no reason for me to keep track of the entire best string on every stage. But I don't know. I guess it's a little bit rusty even on that algorithm. I think in theory I could have I don't know. I think in theory I could have done a little bit faster even on that one. But yeah, but I actually so I'm gonna skip ahead on the commentary, but feel free to watch through it. Basically, I make a couple of mistakes because and you can kind of see the first thing here. I mean, you can do it with dynamic programming, or at least I did it with dynamic programming. But one is see if you can find the ad hoc method to solve this one. Clearly, a lot of people did, so it's doable. I think I was just a little stubborn, or I got too deep into it, too deep. But the big mistake I have here was that I was saving the entire string as part of the memorization, and that was just too slow because I was using it in parts of the calculations in different places and so forth. Would not recommend it. And then as an optimization, I hit on. I was like, oh yeah, wait, you just need the length, and then you could use path reconstruction in dynamic programming, which maybe works in general, but I did it in C++ because Python was running a little bit slow. Was giving me time limit exceeded still. So yeah. So then so I did all that and then I converted to C++ and then I solved it that way. Um, but yeah, so for Q3 I did it in a unnecessarily hard way. Um, but yeah, pretty unfortunate actually. uh, but yeah, I'm gonna skip ahead. You can watch or there's a link on the description so you could skip ahead easily. So do that. Yeah. Can't tell if it's just me or the server's having issue. I click on. What did I click on? I click on submit. So I submit, yay, it works, and I was very relieved that I didn't have to figure out how to do that part the right way. Yeah, Stone Games 3. Yeah, this was, to be honest, very like I knew how to do it immediately. I think I misread the problem a little bit for a minute. In that I thought it was taking from the first pile, or like you give an n piles, each pile has n stones, and you're taking 1, 2, or 3 from the first pile. So that was not the problem. But that's what I thought it was for a second. And I'm just trying to read this form. I mean, I think, and I refreshed the page. I was like, 100 people solved this already. So, so I had to kind of speed that up. I mean, I want to say basically most of this round I did okay, but yeah, problem C, ad hoc string problems are always a little tricky, and I did not do well this time. Well, I guess I didn't do well last time either, but that's another story. Because if I had done this in a more recent, or if I did problem C in a more reasonable time, I've gotten this one much faster, and I probably have a pretty good rank. Even if I took 20 minutes on problem C, I would have gotten good rank. Would have been top 50. So, so I have plenty of time. I just, well, I did even worse than that. So. But yeah, the idea here is dynamic programming, or in my case, memorization, because apparently I'm lazy. And the thing to know is that n is 50,000, so I do take some time to be careful. But otherwise, it's just brute force. Like, hey, because the states don't change, let's just take the first, like whenever you're at the current state, it's like, okay, let me try taking 1, 2, or 3, 1, 2, 3. Stones, and then some, get the score for that, and then yeah, and then take the best out of that. And game theory minimax wise, you just take the subtraction of the recursion. So I mean, that's something that if you didn't or haven't studied enough game theory, or just Leetcode problems with similar things, it might be a little bit longer, or like you may not come to it immediately, but that's essentially it. I mean, this is pretty much it. So I really should have gotten this. So I actually finished this in about 8 minutes, but like I really should not have. So let's see what I waste my time on. I mean, there are a couple of mistakes for sure, but like in terms of concept, this is pretty much like it. And I end up spending 6 or 7 more minutes here. I have a score not defined, so yeah, I mean, I have to. I don't know. I think this is also one of those things where like I was so like I knew this problem, so I was rushing it a little bit in terms of just testing it. I mean, not submitting necessarily, but I was just like missing obvious stuff, like all that stuff. So that actually didn't take that long. So 40 seconds. Recursion limit. I think here I actually spent a couple minutes, so that was just dumb. I think in my mind, when I was writing the base case, I knew I needed to handle it, but I think I just forgot by the time I got to it. So maybe again, sluggish because I just woke up. That's my excuse for everything today. But I needed to do this anyway. But the recursion limit. But that wasn't it. I mean, like we have n is equal to 7, right? Like even as I was doing it, I was like, oh, I'm not sure. So let's print it out. There are a couple of mistakes though, of course, but it should not. These kind of mistakes don't usually take me this long, and usually I don't make these mistakes too at the very beginning, but yeah, here I was like, oh wait, why is n so high? But then I think I end up printing another one just to kind of make sure. I was like 5, huh? That one didn't even make sense. I was trying to think about it a little bit. I could have written this much less dumb, but that's the way I did it. I was like, oh, okay, at least that works a little bit better. Ends as well. I was like, oh, 5. What? How do you get 5? Well, how you get 5 is not being familiar with your libraries, and also like I was just, I think I was still thinking about, not thinking about it, but the same thinking from the first problem where I just keep on taking values off the front, and in theory that's right, but because I don't modify the stone value, I have to debug that. Like it has to be starting from the index, which is pretty obvious, especially in retrospect. But even at the time, but I had trouble seeing it, I suppose. But yeah, but now that I printed out, it's like, oh, what am I doing well? Well, what I'm doing well, as I said, like I just didn't. Yeah, and then once I did that, I was okay. I think I have one more mistakes here, so that took about 2 3 minutes to debug, which is kind of sad. I was like, oh, okay, this is mostly the right answer, but I'm getting tired looking up. I'm like, oh, Bob. I'm also glad that that's one of the example cases. Otherwise, it would have cost me another 5 minutes because I was pretty confident at this point. Um, but yeah, and seems like I end up taking a bit of time debugging this one. I think if I print out the final score, it is very obvious. Well, I guess I kind of see that here too because I was like, oh, score is 0. Why would it be? How can? I think I end up. Um, so yeah, you got to really check your default values and best cases. Uh, and I was a little bit not on top of things today. And then yeah, as soon as I saw that, I was like, okay. So yeah, so I finished at about 44 minutes. I do end up spending 2 more minutes on this one, uh, just to because the way I did it, I think if I did it with a for loop and an array, then I wouldn't have to do this. But because I did this recursively, I really needed to because if you do it with a for loop, 50,000 is way fast, right? But because I did it recursively and with an array or whatever, or recursively, um, and it goes 50,000, maybe a little bit slow. So I really want to double check. I mean, either way, I'm too slow, I suppose. But yeah, but that's what I'm trying to do, and I end up spending a couple of minutes testing the n is equal to 50,000 k's in a way. So that's pretty much it. And once I got that, I submit, and that was good. Anyway, overall, I want to say a good day. One hiccup on a C, but maybe I'll learn about it later. Anyway, thank you, and hope you stay watching for the explanation later for the problems. And I mean, I spent way too long on C. Probably should have done it. Maybe there's a fancy algorithm for C. Yeah, and the 5 minutes doesn't help. And I should have tested that too. So then maybe there's a greedy algorithm for C that I didn't see. No pun intended. 46 minutes or 51 minutes. I mean, it is what it is. I think I was just stuck on C. Also should have done D a little bit faster, but I had some off. Well, I was just doing it dumbly. But yeah, not gonna be top 100, but that's okay. I mean, I guess there's some heuristic. I did it with dynamic programming, which is way hard, and also in C++, so that's probably not the way to do it. But that's the thing with these string and ad hoc problems, is that sometimes it's just hard, or like sometimes you just don't see the thing. I mean, that's probably a greedy one where you just take the max and then you keep on taking the max. There's some like math of like, okay, if I didn't want it to prove it, that's why. Okay, let's go over the problems real quick. Definitely not that fast today. I was really fast in the first two. I feel like. I mean, maybe that's where the rank 14 came from. But the third one got me. I was a little bit slow in the last one too, even though I knew how to do it immediately. Just a little bit slow in the implementation, and also, well, I was a little bit careful at the end, but I should have been careful here as well. But yeah, let's go over the problems. But I feel like I feel a little bit better on this one. At least I was more careful. Even though that one was very testable, so I was pretty dumb. But yeah, I mean, I guess clearly there's a greedy algorithm that I didn't really see looking at these times. Well, I didn't want to prove. I think that was my thing. Like, I quite figured it out, but yeah. All right, let's go with the problems. Problem one. Minimum sequence in non-increasing order. I didn't do this super fast, but I did it okay speed. 2 minutes 13 seconds. Yeah, I mean, I don't know why. I'm just a little bit sluggish right now. I mean, well, I guess maybe it's just because I just woke up. That's my excuse. But because I knew how to do it immediately. I knew it was greedy. I double checked to make sure that you could sort it. Was if you could sort it and you just keep on going until that's the case. They give you a lot of reading, and the criteria just makes it so that the greedy works. And you got done this in a not dumb way. I did in a n square way, really unnecessary. But like this, I don't. Yeah, I think I'm just a little bit sluggish waking up, because this you could just subtract from nums, and then this is just moving the index. I don't know either. But anyway, still, but that shows you that for easy you could get away with a lot of stuff. I just did it really brute force n squared. Probably would not appear any suggested solution anywhere, and it still passed. Numbers of steps to reduce a binary. You could do this much better. Basically, it's you could shift and then you could do keep track of a carry bit. But I was a little bit or a lot lazy, depending on how you want to say it. And wow, people are fast too. I mean, I think, well, yeah, you could just keep track of the carry, because if it's odd, that means you just keep track of the carry. If it's even, you divide by 2 anyway, and then just keep on doing that. And then just keep on doing that, and you do a for loop through the way, and then that should be good enough. I was a little bit lazy. I knew that in Python you could use big nums, so that's what I did. I actually convert the number to a binary number that could be up to 2 to the 500, and then I just do right shift all the way through to count the yeah, I just followed this thing. Um, but that's half cheating. But that was deliberate though. So like it wasn't like I did it by accident. But I wasn't super confident about this one as a result. That's why you probably saw me test the really big case or the 500 digit case. I didn't should have tested the 500 ones case, but yeah, but that's this one. Just follow the thing. Longest happy string. I mean, I think this one I just was really avoiding trying to prove that. I mean, I took 30 minutes on this one. I was just really trying to avoid proving some kind of heuristic that works. I was trying to do basically I brute force, right? Like I tried every combination, and then I reconstructed dynamic programming. Um, won't recommend it. Not gonna lie. I mean, I think there's some heuristic that you could probably figure out, but have to prove to yourself. Where like, okay, like greedy, take the large one. Can you do one? Can you take two? And like you do some math on the remaining ones to see like how you fill the gap, and then just kind of keep on doing it. And then once they're all the same, you just do one from each. So it's not that big of a deal. Um, yeah, maybe I'll play around with it. Like maybe the algorithm is take the biggest one and then take two, and then take one from the minimum or the maximum of the remaining two, and then keep on doing that until they're all equal. And then when they're all equal, then just do it, ABC iterating or something in some order. Maybe that works. That would be my intuition now that I see the time. I think sometimes I refresh the time in the middle just to see if, because the way, in the sense that I sanity check, because the way that I'm doing it, there's no way that reasonable people would have done, or not no way, but like, no way, but the top people would give you a hint on how to solve it. And yeah, I don't know. I definitely did it in a crazy way. Wouldn't recommend it, but it is a solution anyway. But it was just not performant enough in Python to have to convert to C++ to make it performant. So definitely not the solution, but it works. It took me half an hour, and I think the half an hour maybe it's okay. I mean, or like I can accept that given that I didn't want to do the other way. But the 5 minutes was dumb because that was just like it wasn't even like I had to type a big example. It's just 100, 100, 100, 100. I don't know why I didn't try it. I think I was just like a little rush. I was like, this actually works. Like I was so relieved that it works that I just didn't test it because I was just a 45 minutes. Otherwise, where would I have been at 46 minutes? It's still not top 100, so maybe it doesn't really matter. But yeah, wasted really fast first two problems though. Yeah. And then Stone Games. I really should have done this one faster. I have to kind of look back to see why it took me 10 minutes. I mean, I think this was one. I had an off by one somewhere. That was one. But that shouldn't have taken that long. I know how to do this almost. I think, well, one thing that I wasn't sure, well, I think I was slow in reading it, was that I didn't know if they meant like 1, 2, 3 stone from the first row, like only from the first thing. You could take the number 1, 2, or like subtract 1, 2, or 3 from it. So that's how I read it initially. That probably slowed me down. And I think there was just a lot of reading and making sure. So that probably took like a minute or two. But otherwise, I really should not have taken 11 minutes. Like this really should have been a 5, 6 minute problem at best, where it was. So I know all the things about it. There's some game theory that's a little bit like min max. That's a prereq. I mean, you could probably intuit, like figure it out by intuition, but I think that's like a little bit hard to do that without the game theory background, or if you just done enough Leetcode, which has similar problems. Yeah, well, I think I also spent a minute though just testing, because I really wanted to test the n is equal to 50,000 case, especially the recursion limit is the bigger one that I want to make sure about. but yeah. And the thing is also you could, I mean, you could do this in a way. This is actually not that hard. You just it's like, I mean, I mean, this why this function is pretty simple to take a look at, but I didn't want to think about it again. I mean, well, or I was trying to rush it a little bit, uh, like a risk trade-off thing, but it still took me 11 minutes. So I don't know. But yeah, but basically this is just exhaustively doing, okay, let me take one stone and then recursively do a negative on the rest of the stones and then so forth. Um, and that should be good enough. And then you try for 2 and then 3 and then recursively do that. And it could have negative numbers, which you kind of play around here, and that's fine because that's factored in. But I had 0, which was kind of dumb. That's why all these the tiebreakers was tied, but that took like 20 seconds to take. And the sys test, the server was pretty fast today, so I was pretty happy with that generally. Other than maybe on C, was a little bit slowed down, but okay. So I mean, I don't know, top 200 maybe, but I feel like another opportunity lost again. But we'll have to see what the solution is for C. I definitely could have done that better, but or maybe not even top 200 when the other servers merged in. But in general, I probably don't have that much to complain about D and A or B. It's just that ad hoc forms are kind of tricky sometimes, and yeah, and I did it in a crazy way. So, okay, well, thanks for watching the stream, and you know, hope y'all good decoding and hit the like button, hit the subscribe button, and that's all I have for tonight. See y'all next week. Bye bye. Hello, back again. I'm going to try to do the code review portion. Yeah, maybe 148, which is okay. I mean, I think it'll be a little bit lower once the Chinese server gets merged in. But oh man, now it's loading. Yeah, let's do a little bit of code review. I haven't done this in a little bit. But yeah, let's take a look at what our. I actually beat him on the first 2 problems in theory. I mean, he might not be exclusively working on these, but kicked my butt on Q3. But yeah. I don't need to look at this one. But also, it's loading slow anyway. Slowly. I don't even care about Q3 real quick. Well, so I guess it's some sort of greedy. So iterate once. This is like a heap type thing. Like a lazy heap because the n is 100, 300. So but yeah, but okay. I mean, I feel sad for solving in DP. So you do one at a time. I mean, I guess I have to sit down and figure out the proof because I think this, like, tell me that this is good enough. It's a little, you know, I don't know, but I mean, and then you just take the first one. That's good. I thought you have to take maybe the max at least, but it seems like you just take the first one. That's good. Okay, well, that was a waste of half an hour because if I have, yeah, there's a lot of ifs in my life. But the last one I think is easy True. Yeah, I mean, okay, that's pretty much what I did. So, and he did in 3 minutes, which is how I should have done it probably in a good way. But yeah. More greedy type things. But yeah, okay. I mean, I think it's always a little. I don't know. I think most of my memory, my muscle is my mental muscle is just trying to figure out, prove to myself how this is correct. But well, this is cute too. I mean, this is greedy, but in a brute force kind of way because there's only 3 possibilities. And then just kind of try them out. That's like a tiebreaker thing. But oh well. Okay. Well, thanks, friends. We'll see you next week. Bye bye.